is Muhammad Shazwan. So today we are going to do experiment 8, which entitled as a loss of containment of gas. So our team member here is Jilin, and this is Husna, and our cameraman here is Imran. I'm going to pass to our teammate to explain further.
So this is our equipment for our experiment today, and here we have the pressure indicator, and this is the compressed air inlet to fill in the air inside the tank. So this is the air tank, and here we have different size of orifice and orifice at different level. And this is the stopwatch we use to record the discharge time, and this is the ear muff we use to prevent our ear.
For experiment A, our objective is to determine the effect of pressure head maximum flow of the orifice at the different size but at the same level. Fill the tank until 1 bar. Okay, after that, we will open valve 1 and during that time, at the same time, we measure the discharge using the stopwatch. Okay, and we repeat the first. For the second step, we repeat the same procedure again for valve 2A, 3, and 4. And for the last step is we repeat the same step like the first one, but using the different pressure from 2 bar until 4 bar. Okay, now we proceed to our next teammate.
So for experiment B is the same as experiment A. It is the difference in level at the same orifice size. So the first step, we will fill up the tank with 1 bar of pressure using from the compressed air inlet. After that, after the tank is filled up with 1 bar of pressure, after the tank is filled up with 1 bar of air, we will open the valve 2A, and then during the discharge of air, we will record the time until all the air inside the tank is fully discharged. And then the steps is repeated from fill up the tank until discharging the air using different level for level 2A, 2B, 2C, and 2D. And then all the steps is repeated using different pressure of air. The first graph for the first experiment shows the relation of discharge time of air from the gas containment tank with orifice size. The larger the diameter of the orifice, the shorter the time taken for the air to discharge completely from the gas containment tank. This is because the larger the diameter of the orifice indicates a higher cross-sectional area from which allow more air particles to discharge completely from the tank. The second graph for the first experiment shows the relation of instantaneous mass flow rate of air from the gas containment tank with orifice size. The graph shows that largest diameter of orifice has highest cross-sectional area and a shorter discharge time. Larger diameter of orifice allows more air to discharge completely in a shorter time and hence has a higher instantaneous mass flow rate since more air can be flowed through the orifice per unit time. The first graph for the second experiment shows the relation of air discharge time from gas containment tank with different orifice level. From the graph, the air discharge time is fluctuated with orifice level for all different pressure head. This is because gas wholly occupied the tank in which it moved in a random position in the containment tank. The air will be discharged as long as there is pressure difference between inside and outside of the tank, and it is independent of the orifice level of the tank. The last graph for the second experiment shows the relation of instantaneous mass flow rate of the air in the gas containment tank with the orifice level. The instantaneous mass flow rate of the air is constant for all levels of orifice with same orifice diameter at all pressure head. This is because instantaneous mass flow rate is affected by the diameter of the orifice. Since the diameter of the orifice is constant at 2.8 mm for all four levels of orifice, the all pressure head, the instantaneous mass flow rate of air is therefore constant for all four levels of orifice. That's all from us. Thank you.